On December 10, 2024, Elon Musk dropped another bold claim. Posting on X, he said the Boring Company could build a tunnel connecting New York to London. Yes, a transatlantic tunnel, for just $20 billion. And if that wasn't ambitious enough, the trip would take only 54 minutes, a fraction of the 8-hour flight time travelers endure today. To put it into perspective, estimates place the cost at a staggering $20 trillion, making Musk's proposal feel more like science fiction than reality. Yet this wouldn't be the first time Musk turned a seemingly impossible idea into reality. Years ago, he promised reusable rockets with SpaceX, an innovation many dismissed as fantasy. And today, they're a cornerstone of modern space exploration. So what's the truth behind Musk's latest statement? Is it another bold vision that could redefine what's possible, or is it a step too far even for him? Let's find out. The idea of a transatlantic tunnel first appeared in literature back in 1888 when Michel Verne, the son of Jules Verne, imagined a vacuum tube train crossing the Atlantic in his story, An Express of the Future. Over the years, the idea began to move beyond fiction. In the early 20th century, Robert H. Goddard, known as the father of rocketry, patented designs for intercontinental tunnels. Science fiction writer Arthur C. Clarke also wrote about these tunnels in his 1946 short story Rescue Party, and again in his 1956 novel The City and the Stars. While these were imaginative takes, they inspired engineers to think about how such a tunnel might work in the real world. Interest in the concept grew in the late 20th century. In the 1960s, engineers proposed a near-vacuum tube stretching 3,100 miles across the Atlantic, featuring maglev trains that could reach speeds of up to 5,000 miles per hour. Swiss professor Marcel Juffer later suggested a similar idea in the 1970s. Then, in 2003, the first method, subterranean drilling, would involve boring beneath the seabed, similar to how the Channel Tunnel, which connects England and France, was constructed. Spanning 50 kilometers, or 31 miles, it took 6 years to complete and is considered one of the greatest engineering achievements of its time. Now, imagine scaling that up for a transatlantic tunnel, which would need to stretch approximately 5,800 kilometers, or 3,400 miles. At the same pace, construction could take over 700 years to complete, highlighting just how monumental the challenge truly is. Not just that, the tunnel would need to descend up to 5 kilometers, enduring pressures of 400 atmospheres. For perspective, this is similar to the conditions faced by the Titan submersible operated by OceanGate, which tragically imploded in 2023 during a dive to explore the Titanic wreck. The route would also cross the Mid-Atlantic Ridge, a tectonic plate boundary running through the ocean that is highly seismically active. A tunnel crossing this region would need to withstand earthquakes and tectonic shifts, requiring unprecedented engineering solutions. Another proposed method takes a different approach, assembling prefabricated tunnel sections underwater. This technique has proven successful for smaller projects like the BART Tunnel in San Francisco. It's also been used for the Fehmarn Belt Tunnel between Denmark and Germany, which at 18 kilometers will become the world's longest immersed tunnel once completed. You should check out our video on this project. However, scaling this method to handle the Atlantic Ocean's depths and pressures would require producing 54,000 sections, each weighing 30,000 tons, to be produced in 225 factories operating non-stop for 20 years. However, the immense depths and extreme pressures of the Atlantic Ocean make this method also impractical. Faced with these challenges, engineers turn to the most innovative idea yet, a submerged floating tunnel. Unlike traditional tunnels, this structure would float about 150 to 200 meters below the ocean's surface, avoiding the crushing pressures of deeper waters while staying clear of ship traffic. Its multi-layer design promises durability and safety, but its construction would require assembling 33,000 sections under complex oceanic conditions. The effort would demand fleets of submersibles, groundbreaking engineering, and unprecedented global collaboration. While no submerged floating tunnels have been built yet, research and planning are underway in several countries. Norway has proposed the Bjørnafjorden crossing, a 5.5-kilometer concrete tunnel that would float just 30 meters below the water's surface, held in place by tension tethers. The challenges of building a transatlantic tunnel aren't just technical, they're financial. With costs projected to reach an astronomical $2 trillion, why so expensive? The cost stems directly from the scale of the project and the solutions needed to overcome its unprecedented challenges. First, consider the materials. Building such a tunnel would require about 1 billion tons of steel, more than half of the world's annual steel production. On top of that, producing tens of thousands of prefabricated sections, each weighing tens of thousands of tons, would require enormous factory capacity operating non-stop for decades. Then there's the labor. Constructing 5,800 kilometers of tunnel under extreme conditions would involve thousands of highly specialized workers, fleets of submersibles, and equipment capable of withstanding the pressures of the deep ocean. These resources would need to be coordinated across multiple nations over several decades. Even the design itself drives up costs. A submerged floating tunnel, for example, would require innovative materials, advanced anchoring systems, and constant monitoring to ensure its stability against underwater currents, seismic activity, and impacts from marine life. Finally, maintenance would add to the price. A tunnel of this magnitude would need cutting-edge safety systems, regular inspections, and repairs to keep it operational over its lifespan. And since it would be the first of its kind, every step would involve additional research, testing, and trial and error. Ultimately, these factors combine to produce a cost so immense it exceeds the GDP of most countries. For example, the GDP of the United States in 2024 was estimated at $27 trillion. Let's not forget about the promised travel time of just 54 minutes. Even if the engineering and cost challenges of the infrastructure were somehow resolved, what vehicle could travel at the incredible speed required to make the 3,400-mile journey in under an hour? A vehicle would need to maintain an average speed of roughly around 4,000 miles per hour. Expectations revolve around the cutting-edge concepts of Hyperloop and vacuum trains. These technologies operate using magnetic levitation within low-pressure or vacuum-sealed tubes, drastically reducing friction and air resistance to enable extraordinary speeds. Early tests showcased the potential, but also highlighted the gap between theory and practice. In 2020, Virgin Hyperloop conducted a 500-meter test run in a pod designed by Big, reaching a modest 100 miles per hour. More recently, in 2024, a Swiss team achieved an 11.8-kilometer journey at just 25 miles per hour, an improvement in distance, but still far from the ambitious speeds required. Meanwhile, China tested a vacuum maglev train that reached an impressive 373 miles per hour within a 1.24-mile test tube. These advancements demonstrate progress, but the speeds achieved remain significantly below what's needed for a transatlantic tunnel to deliver on its 54-minute promise. And yet, Elon Musk has boldly claimed that his boring company could make it happen, not for 20 trillion, but for just 2 billion. A striking reduction in cost that raises as many questions as it does eyebrows. But can the lessons from the boring company's projects, like the Vegas Loop, scale to meet this challenge? Let's find out. In 2013, Elon Musk introduced the world to his concept of supersonic Hyperloop systems, envisioning pods zipping through vacuum-sealed tubes between Los Angeles and San Francisco at speeds of up to 700 miles per hour. Early on, the boring company seemed poised to make this vision a reality, with its tunnels envisioned as the backbone of Hyperloop systems. However, the challenges quickly became clear. Developing vacuum-sealed tunnels capable of supporting such speeds over long distances posed significant engineering and cost hurdles. The Hyperloop concept required cutting-edge technology and immense funding, not to mention overcoming regulatory barriers. By 2018, the boring company pivoted to a more practical and achievable goal. Instead of pursuing Hyperloop's high-speed promises, the company introduced its Loop system, underground tunnels designed to move passengers in Tesla vehicles. The shift prioritized simplicity, with tunnels that didn't require vacuum environments or maglev technology. Today, the Las Vegas Convention Center, LVCC, Loop became the first operational example of this approach, which provides real-world data to analyze Musk's claims about a transatlantic tunnel. The LVCC Loop spans just 1.7 miles of twin tunnels, constructed at a cost of approximately $53 million, roughly $31 million per mile. By contrast, a transatlantic tunnel would need to stretch around 3,400 miles under the ocean. At the same cost per mile, the total price tag for such a tunnel would soar past $15 billion. And this doesn't even consider the vastly different challenges of boring under the Atlantic compared to the soft desert soils of Las Vegas. Building the LBCC loop took just 17 months, with tunneling rates of about 49 feet per day. At that speed, it would take over 1,000 years to complete the 3,400-mile transatlantic tunnel. Clearly an impractical timeline. While Musk's work with the boring company is impressive, the scale and complexity of a transatlantic tunnel present a whole new level of challenges.